Okay, ladies and gentlemen, welcome to the second of 4 videos for Section 4-5 in your geometry textbook. Again, Section 4 and Section 5 of this chapter cover a very important topic in geometry, that is proving triangle congruence. In the first video for Section 4-5, we finished covering the 4 major postulates by covering the angle-angle-side and angle-side-angle congruence postulates, which followed up on the Section 4 videos, which covered side-side-side and side-angle-side in its 2 videos. So now we just have one special case situation left to talk about in terms of introducing material, and that is going to require us to remember vocabulary involved in right triangles. Remember that in a right triangle, the side opposite the right angle is known as the hypotenuse. The other 2 sides are known as the legs. And in certain situations, they do get more specific names, but that ability to name the hypotenuse is very important with the Pythagorean theorem. So hopefully we already knew that the hypotenuse is the longest side of a right triangle and that it always lies across from the right angle. Now the reason why this is important is because for triangle congruence, there is one additional postulate that applies only to right triangles, hence why the word right appears several times in the wording. Okay, and again, we've got these right angles indicated in the picture. We cannot, repeat, cannot use this theorem unless we are looking at a pair of right triangles. If you do not see an indicated right angle, you cannot use this theorem, the hypotenuse-leg congruence theorem. The hypotenuse-leg congruence theorem says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse, really would help if I could write, there we go, and leg of a second right triangle, again notice the word right, it only applies to right triangles, then the right triangles must be congruent. So in the picture we have right triangles, and we have the hypotenuse, that AB is congruent to DE. Those are the hypotenuses. I'm not sure if that's the right plural, hypotenuse. The hypotenuse of the first triangle is congruent to the hypotenuse of the second triangle. And we have a set of legs. AC is congruent to DF. That alone, combined with the fact that both are right triangles, we have enough information to say, so this isn't really an if. If that's true, then triangle ABC must be congruent to triangle DEF. Because if we have 2 of the 3 sides in a right triangle, using the Pythagorean theorem, we actually have all 3 sides. So this theorem is sort of a special case of the side-side-side congruence postulate combined with the Pythagorean theorem. So to recap, when we're trying to declare that 2 triangles are congruent, there are 5 ways to do that. They're illustrated here on this screen. There are 4 major congruence postulates. The side-side-side congruence postulate, which says 3 sets of congruent sides. The side-angle-side congruence postulate, which is 2 sets of congruent sides and 1 set of included angles. The angle-side-angle postulate, which is 2 sets of congruent angles and the included side. And the angle-angle-side congruence postulate, which is 2 sets of angles and the non-included side. Then we have the one special case theorem, the HypLeg theorem, which applies to right triangles only, which says if we have a hypotenuse and a leg of a right triangle set, that is enough to declare those triangles are congruent. So the last thing on this video is going to be the major non-proof skill in this section, which we actually saw illustrated in a video last section as well with less options for answers. It says determine which postulate or theorem could be used to declare each pair of triangles congruent. If it's not possible, state not possible. So again, I want to go back and state there's 6 problems here. You have to answer with one of these 5 theorems or postulates or not possible. Okay? So as we're going through here, again, there are things we're allowed to add to these pictures. For instance, in number 1, we could declare that these two angles are congruent because they're vertical angles. We're allowed to mark vertical angles as being congruent because our vertical angle theorem says vertical angles are always congruent. In addition, we have these parallel markings, which indicate that we actually have two more sets of angles we are allowed to mark, because these angles are just marked with two dashes. If these lines are parallel, then we have a transversal, and those are alternate interior. Using the exact same argument, we could just as easily mark these two angles as being congruent because they also are alternate interior angles, which means there are actually two correct answers for this first problem. We could declare those triangles congruent with either angle side angle or angle angle side. On the second problem, the things we're allowed to add are a little bit harder to see. Again, we've got parallel markings, and I wouldn't mark these as being parallel unless there was something we could add to the picture. So if we look carefully, we see the parallel lines, which makes this a transversal, and it makes these angles congruent because they are corresponding angles. Using the same sort of argument, the other set of parallel lines also have a transversal, and these two angles would be corresponding, so we can mark them as well. Notice that is enough information for us to state angle side angle. Now in reality, we could use the third angle theorem to declare angle angle side, but what we've marked would be angle side angle. On number 3, we see the right angles. That should immediately be a dead giveaway that we should be seeking HypLeg as our option. We already have a set of legs marked in our right angles, and we have a congruent hypotenuse. That is enough for us to declare hypotenuse leg and finish that problem. On number 4, the only thing we can add to the picture is a set of vertical angles, and unfortunately that is not enough information for us to complete the problem because that is not side angle side. That would be side side angle or angle side side, and that is not an acceptable reason. That does not guarantee triangle congruence. So that's a not possible. Number 5, we have the reflexive side that we can mark, which is enough information to complete by side side side. Number 6, we have the reflexive side, which is enough for us to state angle angle side. Again, any proof that can be completed angle angle side could also be completed angle side angle. So either answer should in theory be acceptable, although angle angle side is what we have shown in the picture. That does it for the second of 4 videos for this section. The next video is going to show 3 example proofs, just so that we have some additional example proofs to look at as we go through our assignment. Thank you very much for your attention.